Welcome to another episode of the More You Know Show. Today, we are going to give an overview on the science of plastics and how plastics are separated to be recycled.
Plastics are synthetic or semi-synthetic organic solids. The raw materials that are used to make plastics are crude oil and natural gases, which are non-renewable resources. Plastics are very durable and degrade at a sluggish pace, persisting in the environment if not reused or recycled.
In order to recycle plastics, they must first be separated by their resin identification number. Separating plastics is complicated because there are many different kinds of plastics. Currently, plastics are separated into only 7 categories. Type 1 PET plastics are usually transparent and make up the vast majority of disposable soda and water bottles. Type 2 HDPE plastics are usually opaque in color and include most milk jugs and detergent bottles. Type 1 and 2 plastics are the most commonly recycled out of all 7 because they are the most abundant, have the most desirable properties, and there is a large market for the recycled plastic. Type 3 PVC plastics include food wrap and PVC plumbing pipes and are rarely accepted by recycling programs because the plastic cannot be melted and reformed without changing its properties, and there is no market for the recovered plastic. Unfortunately, it's then sent to the landfill or incinerated, and if PVC is burned, it releases chlorine-containing compounds that are highly toxic or can damage the ozone layer, or both. Type 4 LDPE plastics are used to make grocery bags, squeezable bottles, and bread bags, which are difficult to recycle. In order to be recycled, the recycled plastics need to be mixed with raw materials to regain the plastic's original properties. At present, since it is much more cost-effective to produce new Type 4 plastic, the used plastic is thrown away. Type 5 PP plastics are used to make medicine, ketchup, and syrup bottles. This plastic is increasingly being accepted by curbside recycling programs because of its growing abundance. Type 6 PS plastics include disposable containers, packaging, and styrofoam plates and cups. They are not widely accepted by recycling programs because there is a weak market for recycled Type 6 plastics. Type 7 plastics are other plastics not included in groups 1 through 6. Type 7 plastics are often present in sports equipment, CDs, DVDs, and even iPods. Since Type 7 plastics are mixtures, they are difficult to recycle, and most curbside recycling programs won't accept them.
In New York City, only Type 1 and 2 bottles and jugs are collected for recycling, in part because sorting is so difficult. Plastic bottles are collected and sent to Sims Metal Management Municipal Recycling. Items containing Type 1 or 2 are sorted using lasers and then sold to private companies. All of the other types of plastics are disposed of in a landfill.
But why does this matter?
Since non-recyclable plastics use vital natural resources, take up space, and damage the environment, it's important to come up with efficient methods of recycling plastics. Currently, only 45% of plastics in New York City's garbage are recycled.
We experimented with various methods that are being developed to sort plastics more efficiently. The methods we tried include separation by flotation, magnetic density separation, electrostatic separation, and dissolution. The first 3 methods separate plastics based on density. Electrostatic separation sorts plastics that have been electrically charged, and dissolution separates plastics based on the temperature they dissolve at in different liquids.
Did you know that every type of plastic has its own specific density?
No way!
Well, you're silly. Ha 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 ha! For the flotation method, we took advantage of the fact that each type of plastic has a different density and prepared 5 solutions with specific densities that covered the gaps between the densities of the 6 main types of plastic. Square pieces of the 6 types of plastic were submerged in the solutions and were separated based on whether they sank or floated until they were classified into 6 distinct groups. Based on which solutions the plastic sank and or floated in, their types were determined. However, this method does not work for Type 7 plastics, since Type 7 is not just one type of plastic. The different plastics that make up Type 7 will need to be given separate numbers in the near future.
Since all of the plastics have different densities, there is another way to separate them using 2 magnetic solutions. The first solution has a density of 0.99 grams per milliliter and separates plastic types 1, 4, and 6. The other has a density of 1.02 grams per milliliter and separates plastic types 2, 3, and 5. These magnetic solutions are made by dissolving a paramagnetic salt such as manganese chloride in water. Then plastic particles are submerged in the solution and a magnet is applied to the bottom. The closer the liquid is to the magnet, the denser it becomes, and the farther the liquid is from the magnet, the less dense it becomes. This is because the magnetic particles are attracted toward the magnet at the bottom of the beaker. As a result of this density gradient, all the plastics are separated in layers based on their relative densities.
Electrostatic separation is a method which consists of two main parts: a tribal charger, which is a cyclone that frictionally charges small plastic particles, and an electric field consisting of two oppositely charged metal plates. Different types of plastics charge either negatively or positively when rubbed against different kinds of material, enabling an electric field with two oppositely charged plates, or electrodes, to separate the pieces. The charged pieces are sorted in 3 collectors, 2 at the bottom of each charged plate, and 1 in the middle for insufficiently charged particles. The separation method has many benefits, such as low cost, excellent time efficiency, no harmful chemicals, and relatively safe equipment.
The Rensselaer process was developed by Bruce E. Nauman and Jerry Lynch of the Rensselaer Polytechnic Institute. It uses xylene as a solvent for selectively dissolving 6 different types of plastic. Each plastic has a unique temperature at which it starts dissolving, except for number 1, which does not dissolve in xylene at all. For instance, number 6 dissolves in xylene at room temperature, number 4 at 75 degrees Celsius, and number 2 at 105. Other solvents can be used to dissolve plastic, such as acetone, chloroform, and THF, or tetrahydrofuran. After the plastics are selectively dissolved, they are devolatilized, or heated in the absence of oxygen. This causes the xylene to evaporate, leaving only pure plastic. To separate all 7 types of plastic, the Rensselaer process might be very effective because it can separate mixed plastics.
After testing each of these methods on a small scale, we determined that flotation would be the most efficient method for separating type 1 to 6 plastics because of its low cost and ability to separate plastics quickly. Hopefully, New York City will adopt this method or an equally effective method in the near future in order to decrease the amount of plastics in landfills as well as the amount of harmful chemicals released when plastics are incinerated. Thanks for watching The More You Know Show!
The more you know, the better it is.